Alright guys, we're now going to solve a few more inclined plane problems using energy. Let's check it out. So here I have a 2 kilogram block at the bottom of an incline, and we're going to push it up with a force of 20 that is directed up the plane. Okay, so the force is 20 up the plane, so it looks like that. This makes an angle of 37. It's a smooth plane, so the friction is 0. And I want to know, after I've done this for 5 meters, after I've pushed this up the plane, in other words, after I pushed it this way, so that the object is over here somewhere. So after I've done this for a distance of 5 meters, what kind of final velocity does it have? We're going to use the conservation of energy equation because my speed's changing, my height's changing, and there's work done by you. So all these three guys are in the energy equation. So we can solve this very straightforward like this. The initial kinetic energy is 0 because this starts from rest. It says that right there, originally at rest. The potential energy is 0 as well because we're at the bottom. The work done by non-conservative forces is the work done by you, plus the work done by friction, but there is no work done by friction. However, there is work done by you. Okay. The kinetic final is half mv final squared. There is kinetic energy at the end. I'm looking for that velocity, and there is potential energy, so I'm going to replace that with mgh final. Okay, work done by you. Well, the work done by any force is fd cosine of theta. It says here that you push it up the plane, so you push it this way, which is the direction that the object is going to move. So it moves in that direction. The angle between these two is 0 degrees. And the cosine of, because they're perpendicular or parallel to each other, the cosine of 0 is 1, so that the work done by F becomes just simply FD. Okay, let me go ahead and move that FD in here. So FD, let me plug in numbers. The force is 20, and the distance is 5. On the other side, we have half. The block is 2. The final velocity is what we're looking for. The block is 2, gravity is 10, and the final height is, notice that we don't have a final height once again, so we have to use our little equation here. If I know the length or the distance, same thing, and I know the angle theta, I can find the height by using, in this case we're calling it d, so d sine of theta, and that's 3 sine of 37, which is, 5 sine of 37, which is 3. Cool. So height final is 3 meters. That's what goes there. I have everything except v final, so I can now solve this. Okay. This is 100. These two cancel. V final squared plus 60. You move this over. I have v equals the square root of 100 minus 60, the square root of 40. And that gives us 6.32 meters per second. That's it for this one. Let's try the next one.